Welcome back to our YouTube channel Aman Codes. In today's episode, we are going to discuss about Bitwise XOR operator. So, in order to declare this Bitwise XOR operator, we are using this power symbol, right? So, see here syntax. Variable name is equals to value 1 XOR operator value 2. So, the functionality of XOR operator is like this: value 1, value 2, value 1 XOR value 2. When the inputs are different, the output is going to be in the sense 1. When the inputs are different, the output is going to be 1. When the inputs are same, then output is going to be 0. When the inputs are same, the output is going to be 0. When value 1 and value 2 are different, like this: 1 here 0, then the output is going to be 1. So in bitwise operator, the inputs are different, the output is going to be 1. When the inputs are same, the output is going to be 0. So this is a truth table in bitwise XOR operator. So let's see the practical examples in this bitwise XOR operator. So we are going to check the truth table is right or wrong. So 0 XOR operator. So 0 XOR operator 1. The output is going to be 1, right? So same here, 1 XOR operator 0. The output is going to be 1. Why? The inputs are different. So if I try to do this thing, 0 XOR 0, then the output is going to be 0. 1 XOR 1, then the output is also going to be 0. So this is level 1 examples. So we are going to do level 2 examples. I'm going to declare A is equals to 5 and B is equals to 2. So now I'm going to do XOR operation between A and B. A XOR B. So before seeing output, how it will be in the sense. So see here, I want to take binary format of this file. So binary format of this file is 0101. Now I'm going to take the binary format of the value 2. So binary format of 2 is 0010. So now I have to do the XOR operation between these two, 5 and 2. So the inputs are different, then the output is going to be 1, right? So inputs difference, output 1. Inputs difference, output is 1. Inputs difference, output is 1. Here see, inputs are same, then the output is going to be 0. So we got the output as 0111. If you try to take this in 8421 code, if you try to add 4 plus 2 plus 1, the answer is going to be 7, right? So the output of this A XOR B is going to be 7. Let's see it is 7 or not. I'm trying to execute this A XOR B, see here. So we got the output as 7, right? So these type of examples are important in this bitwise XOR operations. So and now I'm going to use like this 3 XOR operator 5. The output is going to be 6. And 5 XOR operator 8. The output is going to be 13. So like this, the output is going to be different when we are going to use this bitwise XOR operator. So if I use this symbol between 2, 3, generally some people they are think like this 2 power 3. So it is wrong. So if it is 2 power 3, in the sense 2 into 2 into 2, right? So 2 to the 4, 4 to the 8, they think. So if I try to execute this 2 XOR 3, the output is going to be like this. See here, 2 XOR 3, the output is going to be 1. But generally people think the output is going to be 8. But it is not. How in the sense, whenever we do 2 XOR 3, we have to take the binary value of 2, that is 0010, and the binary value of 3 is 0011. If I try to do XOR operation, so it is going to do XOR operation. So different bits output is 1, different same bits output is 000. We got this right, and we try to do 8421. At the place of 1, we got 1, right? So this binary format is converted into decimal number system, that is 1. So the 1 is going to get the output as here like this, right? So this 2 power 3 is not is equals to 8. This 2 power 3 is equals to 1. So this is main important thing is level 2 example. So if I try to do 1.2 XOR 2.3, it is not going to be possible. It is going to throw another kind of type error. See here, we got a type error, right? Why? because float values are not uncertain values, right? A is equals to 4, B is equals to 5. I want to swap these numbers in the sense, so I want to put this 5 in A, I want to put this 4 in B. So in order to do swap logic, we are using this bitwise XOR operator. See here, I'm going to use this. So I'm going to swap A is equals to 4, B is equals to 9. A is equals to A XOR B. And B is equals to A XOR B. And A is equals to A XOR B. See, if I do this thing and I try to print A and B. See here, print of A comma B. So before A assigned to 4 and B assigned to 9, right? So first I am trying to print A, then B. So then the output is going to be, first 9 is going to be retrieved. After then 4 is going to be retrieved. See here. So first 9, then 4, right? So swapping has successfully done by using this bitwise XOR operator. So let's see the level 3 examples like this. I'm going to consider S1 is equals to like 10 comma 20 comma 30. Now I'm going to consider S2 is equals to like this 30 comma 40 comma 50. Then I'm going to do S1 XOR S2. It will remove the common elements from the both the sets and it will retrieve the remaining elements from the set 1 and remaining elements from the set 2. See here, the output is 10, 20, 40, 50. See here, if I execute this thing, 10 we have, 20 we have, 40 we have, 50 we have, but 30 we don't have, right? So, but there is no 30, right? So it is said that if it does not maintain instruction order, that is a random order, it has been given as output. So it is going to perform symmetric underscore difference. So symmetric underscore difference of is a function. It is a predefined function which is present in set data type. So we want to do symmetric underscore difference without the symmetric underscore difference. Then we are going to use this bitwise XOR operator. So now I'm going to use this symmetric underscore difference of. See here, I'm going to do S1 dot symmetric underscore difference of S2. What it will do in the sense, it will take two sets, S1 and S2. So it will remove the common elements from the both the sets and it is going to return the remaining elements from the set 1 and remaining elements from the set 2 as a one set. See here. So the output of XOR operator, the output of symmetric difference operator is the same, right? We want to do symmetric underscore difference operation without a predefined function, then the only one thing we have to do that is bitwise XOR operator. If I try to do like this, S1 is equals to 2, comma 3.4 and S2 is equals to like this 3.4, comma 5.6. The output is going to be like this. If I do S1 XOR operator S2, then the output is 1.2 and 5.6. See here, we got 1.2 and 5.6, right? Previously, we have done by considering only float values. So the output is type error, right? So if we declare the float values in set and we do that XOR operation, then it is going to be perform symmetric underscore difference. So if I do this thing, 1 comma 2 comma 3 comma 4 XOR operator and then like this 5 comma 6 comma 7, the output is going to be C type error. So it is not able to do in the lists. It is only sets, not lists. So earphones, XOR operator, and I'm going to do like this phone. Earphone XOR operator phone, the output is type error. It is not going to be possible in STRs. If I try to declare here set of, I'm trying to convert this STR into set, then it is going to be happen. Why it is able in only sets, right? So see here, I'm going to do this thing. It is going to remove the common elements from these two strings and it is going to retrieve the elements which are present in earphones, which are present in phone. This PHONE is not going to come in the output, only the output is EAR. Yes, that's it. So let's try to understand this output. So here we have E, right? So that is the reason E also eliminated, removed. So the output is AR and this ES. So it has performed symmetric underscore difference operation. So internally, Python software developers also using this XOR operator in symmetric underscore difference predefined function. The output is going to be like this. So the common elements from this both sets is going to be removed. P is going to be removed. The output is apple, mango, and RSI. See here, I'm going to execute the statement. Apple, mango, RSI has been retrieved from this XOR operation. This is all about level 3 examples and important examples in this Bitwise XOR operator. That's all for today's episode. In today's video, we are discussed about Bitwise XOR operator. I hope you all understand. Don't forget to like, share, subscribe to Aman Codes. Thank you so much for watching.